Assalamualaikum dear students, welcome to the experiment number 3, determination of Zn+2 in the given sample solution. We have performed this experiment in your lab. The video is regarding the way of writing the lab report. After writing the title, you will write the chemical equations as you have standardized the ETTA solution first. So the equation involved in this standardization you have to write. So equation number 1 is the ionization of magnesium sulfate heptahydrate, in which magnesium sulfate has been ionized as magnesium +2 and sulfate -2, and 7 water molecule, 7 water of crystallization have been separated as well. So you will write in the form of equation. Reaction of magnesium +2 with reactant Lec at pH 10. Magnesium +2 when reacting with indicator, it is forming pink red colored complex. In step number 3, you will show the breakdown of this magnesium indicator pink red colored complex after the addition of EDTA. EDTA is represented here in general form. So magnesium EDTA complex will form and the black टी इंडिकेटर will set free. आपको इनके कलर्स भी रिपोर्ट करने हैं. Just like the magnesium +2 reaction with indicator and EDTA, you have to write the reaction of zinc +2 with reactant T at pH 10. This reaction you will write in under the heading of analysis of zinc +2 in the given sample solution. So zinc when reacting with reactant black tea, it is forming pink red colored complex. And in step number 5, you will write the reaction of zinc indicator complex with EDTA. So it is forming colorless zinc EDTA complex along with the free indicator will be represented in the equation on product side, or again you will report the colors of species. After writing the equations, you will have to draw the structure of EDTA as shown below. After the structure of ligand, you have to draw the structure of complexes. First, magnesium EDTA complex will be drawn. After that, the structure of zinc EDTA complex will be drawn. So it is showing that the ring-like structure has been formed when zinc EDTA complex is formed. होता क्या है कि zinc is surrounded by the EDTA ligand, or EDTA is a polydentate ligand. So when it surrounds the zinc, so it forms a chelate, a ring-like structure around the metal atom. After equations and after drawing the structures, आपने observations की तरफ आना है. In first heading of observation, determination of concentration of diluted standard magnesium sulfate solution. You use the diluted standard magnesium sulfate solution. That means we provided you the stock standard magnesium sulfate solution और उसको आपने dilute किया था. You took 0.1 molar stock standard magnesium सल्फेट सॉल्यूशन, इसका 5 ml लेकर आपने 50 ml मेकअप किया था. सो कंसंट्रेशन ऑफ स्टॉक स्टैंडर्ड मैग्नीशियम सल्फेट सॉल्यूशन C2 was 0.1 molar. Volume of this solution V2 was 5.0 ml. Concentration of diluted standard magnesium sulfate solution C1 you have to find out. And volume of diluted standard magnesium sulfate solution, कितना वॉल्यूम में आपने इसको मेकअप किया था, that was 50.0 ml V1. In the standardization of EDTA solution step, you got the volume of EDTA solution consumed against the standard magnesium sulfate solution. So first, before filling the observation column, you have to fill the observation points like volume of diluted standard magnesium sulfate solution आपने कितना लिया था, you will report here. Volume of buffer solution of pH 10 about 10 ml. You took about 10 ml of buffer solution of pH 10. Indicator you used was ragrom black tea, and after that you will fill whatever the concordant reading for the standardization of EDTA solution. You will fill the observation column. After this standardization step, you have to report about the analysis of Zn+2 in the given sample solution. Again, before filling the observation column, before reporting the concordant reading, you will fill the observation points. Volume of sample solution of Zn+2, volume of buffer solution of pH 10, indicator you have used, volume of standard EDTA solution consumed against 10.0 ml of sample solution of zinc. Next, after observations, come to the calculations. The first step in calculation is determination of concentration of diluted standard magnesium sulfate solution. By taking a known volume of known strength stock magnesium sulfate standard solution, you have prepared your diluted standard magnesium sulfate solution. By applying C1V1 C2V2 formula, you can easily find out the concentration of diluted standard magnesium sulfate solution. So after rearranging the formula, the C1, the concentration of diluted standard magnesium sulfate solution was found to be 0.01 molar. What is step number 2 in calculations? Let's find out. Step number 2 of calculations, the standardization of EDTA solution. 1000 ml of diluted standard magnesium sulfate solution contains 0.01 mole of magnesium sulfate. 1 ml diluted standard magnesium sulfate solution contains 0.01 divided by 1000 mole of magnesium sulfate. So 10 ml of diluted standard magnesium sulfate solution contain, you will multiply 0.01 with 10.0 and then divided by 1000. So in this way you will get a supposed C mole of magnesium sulfate. The important thing after this calculation step is you will apply the mole ratio formula here. What is the mole ratio between magnesium sulfate and ETTA? 1 mole of magnesium sulfate is equal to 1 mole of ETTA. So 1 mole of ETTA divided by 1 mole of magnesium sulfate and multiplied by C mole of magnesium sulfate, you will get D mole of ETTA. After that, the concordant burette reading जो आपको स्टैंडर्डाइजेशन के स्टेप में मिली है, that concordant burette reading you will fill in this blank. Concordant burette reading जो भी आपकी आई है, that is the ml of EDTA solution that contain T mole of EDTA. So 1 ml में कितने मोल होंगे? D will be multiplied by your D will be divided by your concordant burette reading. So mole of EDTA in 1 ml, and then you have to find out the 1000 ml EDTA solution contains how many moles. So D will be multiplied by 1000 and then divided by your concordant burette reading. So in this way you will get the moles of EDTA as E moles, क्योंकि हमने suppose किए हैं हमारे पास E moles of EDTA आए हैं in 1000 ml, and mole per 1000 ml is giving actually the concentration of EDTA solution. So we have E molar solution of EDTA. Analysis of zinc plus 2 in the given sample solution. Here you will use the concentration of EDTA solution to find out the concentration of zinc plus 2 in the given sample solution. So start the calculation. Like 1000 ml standard EDTA solution contains E mole of EDTA. 1 ml में कितना होंगे? And then 1 ml standard EDTA solution contain E divided by 1000 mole of EDTA. After that, CBR means concordant burette reading that you got during the analysis of zinc plus 2. You will put that concordant burette reading here. आप यहाँ पर वो वाली concordant burette reading place करेंगे, and then you will calculate the mole of EDTA in the volume that was consumed against the sample solution. Suppose if you are having 12.0 your concordant burette reading, तो यहाँ पर आप 12.0 place करेंगे. After calculation, E multiplied by concordant burette reading and divided by 1000, you are getting F moles of EDTA. So after that we will apply the mole ratio between EDTA and zinc plus 2. 1:1 का मोल रेशो है between EDTA and zinc. That means जितना मोल EDTA के हैं उतने ही मोल्स zinc के. Here we are getting F moles of EDTA. So 1 mole of zinc plus 2 divided by 1 mole of EDTA and then multiplied by F. So we are getting G moles of zinc plus 2. 10 ml sample solution contains G mole of zinc. So 1 ml sample solution will contain G divided by 10 mole of zinc. 1000 ml में कितना मोल है हम किस तरह से कैलकुलेट करेंगे? G will be multiplied by 1000 and divided by 10. So in this way we are getting H moles of zinc. So the concentration of zinc plus 2 in the given sample solution was found to be H. Determination of amount or weight of zinc plus 2 in the given sample solution. in milligram per 450 ml. You have find out in last step that 1000 ml of sample solution contains H mole of zinc plus 2. हमारे सपोज्ड वैल्यू जो आई है 1000 ml के अंदर वो H आई है, H मोल ऑफ जिंक प्लस 2. 1 ml सैम्पल सोल्यूशन में फाइंड आउट करेंगे H डिवाइड बाई 1000 and after that in 450 ml sample solution you can find out by multiplying this H with 450 and dividing it by 1000. So in this way we are getting a supposed I value, I mole of zinc plus 2. यहाँ पर हमने जस्ट वॉल्यूम कन्वर्ट किया है from 1000 to 450. We have find out the number of moles in 450 ml sample solution, mole of zinc in 450 ml sample solution. Now weight of zinc can be find out with the help of formula. Weight of zinc plus 2 is equal to number of moles of zinc plus 2 into molar mass. We know the number of moles and molar mass, so I have the number of moles into its molar mass 65. We are getting J grams of zinc plus 2 in 450 ml. पहले हमने मोल फाइंड आउट किए थे and after applying the formula we have find out the grams here. But our task is to find out the milligrams in 450 ml. अभी हमें ग्राम मालूम हुए हैं 450 ml के अंदर. Next, see how we can find out the milligrams. We have to apply a relation of gram and milligram, that is 1 gram is equals to 1000 milligram. We have got J gram, so J gram would be equal to J multiplied by 1000. In this way we will get the milligram of zinc per 450 ml. वॉल्यूम कन्वर्ट हम पहले ही कर चुके हैं. आफ्टर दैट हमने उससे मोल की मदद से हमने ग्राम्स फाइंड आउट किए and after finding out the grams we are applying a relation of gram to milligram and then we are getting the milligrams per 450 ml of Our second task is determination of amount or weight of zinc sulfate heptahydrate in given sample solution in microgram per 716 nanoliter. अब यहाँ पर आपको जो important points ध्यान में रखने हैं that you use in the previous calculation you use zinc plus 2. Here you are using the salt of zinc that is actually producing the zinc ions. So let's suppose we have provided you the zinc sulfate heptahydrate salt and you have analyzed zinc plus 2 in your sample solution. With the help of that zinc plus 2 you will find out the amount or weight of zinc sulfate heptahydrate. Let's start. 1000 ml sample solution contains H mole of zinc plus 2. So after that you will apply a relation of 1000 ml, liter and nanoliter. 1000 ml is equals to 1 liter or exponent 9 nanoliter. That means either you write 1000 ml, either you write 1 liter or you write exponent 9 nanoliter. All are the same. That means जो हमारे पास H मोल ऑफ जिंक प्लस 2 आए हैं 1000 ml के अंदर वही एक्चुअली क्या है 1 लीटर में है, वही एक्चुअली एक्सपोनेंट 9 नैनोलीटर वॉल्यूम में है. So we can say that exponent 9 nanoliter sample solution contains H mole of zinc plus 2. So 1 nanoliter sample solution will contain H divided by exponent 9 mole of zinc plus 2. हमें क्या करना है? We have to find out the amount of weight of zinc sulfate heptahydrate in 760 nanometer. यहाँ पर volume conversion B है. We know 1000 ml is mole. तो हमें यहाँ पर मिलीलीटर से नैनोलीटर की साइड पर जाना है और नैनोलीटर भी कितना नैनोलीटर है? 760 नैनोलीटर. So from 1000 ml to 760 nanoliter we are proceeding like 1000 ml is equals to 1 liter और वो equal है exponent 9 nanoliter के. So 760 nanoliter sample solution will contain H into 760 and divided by exponent 9. So in this way we will get K mole of zinc plus 2 per 760 nanoliter. From 1000 ml we have find out, starting from the 1000 ml sample solution small, we have find out the mole of zinc plus 2 in 760 nanoliter. Let's see how we can find out the moles of salt by applying the relation that 1 mole of zinc plus 2 have been produced by 1 mole of zinc sulfate heptahydrate. 1 mole of zinc plus 2 is equals to 1 mole of zinc sulfate heptahydrate. So K mole of zinc जो कि अभी प्रोड्यूस हम हुए हैं, जो कि हमने कैलकुलेट करके फाइंड आउट किए हैं, K mole of zinc plus 2 per 760 nanoliter will be equal to K mole of zinc sulfate heptahydrate. Weight of zinc sulfate can be found out with that of number of moles into molar mass of zinc sulfate heptahydrate. So the molar mass is 287. After putting the values we are getting m gram of zinc sulfate heptahydrate per 760 nanoliter because volume conversion हमने already कर लिया है. Now we are getting the grams here. अब आपको पता है कि in your task you have to find out the microgram. क्या करेंगे? We will apply a relation of gram to microgram. 1 gram is equals to exponent 6 microgram. So हमारे पास क्योंकि m ग्राम प्रोड्यूस हुए हैं तो m ग्राम will be equal to m gram zinc sulfate will be equal to m multiplied by exponent 6 microgram. So in this way we are getting 0 microgram per 760 nanoliter. वॉल्यूम कन्वर्जन भी कर दिया था. जिंक प्लस 2 की मदद से जिंक सल्फेट हेप्टाहाइड्रेट की मोल भी फाइंड आउट किए एंड देन ग्राम की मदद से हमने क्या फाइंड आउट कर लिया? माइक्रोग्राम में. So the amount of zinc sulfate heptahydrate in the given sample solution was found to be 0 microgram per 760 nanoliter. Results that you found out are the concentration of EDTA solution is E molar, the concentration of zinc plus 2 in the given sample solution is H molar. Whatever you are getting you will report here. The amount of zinc plus 2 in the given sample solution is R milligram per 450 ml. The amount of zinc sulfate heptahydrate in the given sample solution is O microgram per 760 nanoliter. Hope you have understand the calculation. Thank you.